Welcome back to part 4, continued. There isn't that much extra you need to be able to do in order to solve a system of equations by changing both of them. So our learning intention here is basically I can find the lowest common multiple of two coefficients in order to make them match. So my system is solvable. So basically you can then do the rest that we've been doing up to now. If you look at those two equations, 2x plus 3y equals 7, 7x plus 4y equals 18. There is no way to easily multiply one of them up so that it becomes, so one of the coefficients becomes the same as the other coefficient. There's no way to turn 2 into 7 that's easy, because then times by 3.5 we'd have to do 3 times, we would end up with halves and we don't like doing that. Same with the 3 and the 4. So what we're going to do is multiply both, but we like to make life easy for ourselves. And that means finding the lowest common multiple. Because yes, I could turn 2 and 7 both into 140. But then all my other numbers would be horrendously huge and would be so likely to make a silly mistake. What we are going to do is look for the lowest common multiple of both pairs. It may be obvious that there's one that's much smaller than the other. So have a wee look. This one is 2 times 7, 14. There isn't anything lower. 3 times 4, smallest thing they both fit into, 12. So there isn't much in it this time, but sometimes you'll get it with 205, in which case, go for the 5. As it is, I'm going to make my y's the same, because the 12 smaller probably, hopefully, makes my life easier. So how do we make 3 into 12? We times by 4. How do we make 4 into 12? We times by 3. When we do this, we're going to have 2x times 4, 8x. 3y times 4, 12y, equals 7 times 4, 28. 7x times 3, we're going to have 21x. 4y times 3, we're going to have 12y. Perfect, they now match. And 18 times 3 is 54. We now have a system of equations with a matching coefficient. And we just continue how we have every other time. X or y. 8, 21, 12, 12. We are going to make the y disappear. How do we make the y disappear? Do they have the same sign? Yes, they're both positive. So we are going to subtract. Set it up. Now, unfortunately, my bigger number's on the bottom. At this point, you are allowed to flip your two equations around. I'm not going to do that, but it is an option. So we have 8 take away 21 minus 13. X plus 0. 28 take away 54, we're going to have minus 26. So x equals 2. Underline for final answer. We look at y next. So we have either of these equations. Again, we can go back to our original equations. We don't have to do these ones where they're blowing up. We can just go to sub in and write down your equations so you don't get yourself confused. Sub in to 2x plus 3y equals 7. So we have 2 times 2. 4 plus 3y equals 7. 3y, the 4 comes across, so it's 7 take away 4 equals 3. Y equals 1. Again, I think I'm just off the edge of the page there. But there we are. We have found x, we have found y. The only little thing we had to be sneaky about was we didn't get to just change one number, and we wanted to be clever and make sure we went for the smallest value we could. If you'd gone for the x's and you'd done the 14s, you should get the same answer. And that's a challenge to you if you fancy doing it after this.